This video focuses on what an acid is, what an alkali is, and the reactions of acids. So, the definition that you need to learn for an acid is that it's a substance that donates H plus ions. Now, if you actually look at an atom of hydrogen, you'll find that it's actually made up of one proton and one electron. And if it's a positive hydrogen ion, that means it's lost its electron. So therefore, a hydrogen ion, an H plus ion, is simply a proton. So acids can also be referred to as proton donors. Now, strong acids, when you dissolve them in water, for example, let's take for example hydrochloric acid, HCl. If I put 100 hydrogen chloride molecules in water, every single one of those molecules would break up. It would dissociate to produce H plus ions and chloride ions. So because we say it fully dissociates, because the hydrogen chloride fully dissociates, that means hydrochloric acid is a strong acid. If an acid is weak, it means it partially dissociates, which would mean that if I put 100 of those molecules in water, maybe only 2 of them would break up to release H plus ions. It would still be an acid because it was releasing these H plus ions, but it would be a weak acid because only a small proportion of our original molecules had dissociated to produce H plus. Now, you often hear referred to alkalis as the opposite of acids. So an alkali is a substance which forms hydroxide ions in solution. And alkalis are actually water-soluble bases. The base is really the opposite of an acid. So if an acid is a substance that donates H plus ions, a base, if we just add it, is a substance that accepts H plus ions. So you can see that acids and alkali react by combining H plus and OH minus, and if those combine, we make H2O. And a substance is neutral if there is an equal amount of H plus and OH minus. Now, that is a neutralization reaction. And what I've just written there is an example. I think I'm going to lose the blue pen at the edge. But you can see neutralization. And that's an example of an ionic equation. You've got 2 ions combining to form water. And that's valid for every single neutralization that you come across. Now, acidity can be measured on the pH scale. The pH scale can actually go down to 0. In fact, it can go past 0, but that's generally not covered at GCSE, and runs between 0 and 14. And the neutral point is 7, and at 7 the amount of H plus and the amount of OH minus is exactly equal. Towards 0, so somewhere down here, we have strong acids, we have weaker acids, we have weak alkalis, and then we have strong alkalis up here, probably above 10 or 11. And acids are you probably classify them as strongly acidic, probably below 3. And we can use universal indicator to test if a substance is a strong acid, if it's a weak acid, if it's a weak alkali, if it's a strong alkali, or if it's neutral. And you should know the colours. So a strong acid is red, and changes into orange, into yellow. Okay, if it's neutral, it's going to be green. Okay, that then turns blue for weak alkalis. Okay, and then you get a nice purple colour occurring for strong alkalis. And everyone says, students that I teach say, universal indicator is the best indicator you can use, because obviously it tells you exactly where on the pH scale our substance is. But that's not quite always the case. Sometimes we want to know simply if a substance is acidic or if it's alkali. We don't want to know the middle ground. And let's take, for example, if a substance was down here on the pH scale, it's probably a bit misleading to put that purple colour there. If it was down here, it might form a light green colour in universal indicator. Now I might think, that's actually a full green, that's pH 7. Someone else might think, that's actually a dark green, so they might think the pH is actually more like 8. So it's very, very subjective when you have this full range of colours. So sometimes it's very useful to have a full range of colours, and other times you simply want to know if it's acidic or if it's alkaline. So is it always the best indicator? Not always. Okay, and these three indicators, you need to know the colours that they go in when they're in acid and when they're in alkali. So methyl orange, it turns red in an acid and it's yellow in alkali. Litmus turns red in acid and in alkali it turns blue. And phenolphthalein, which is my favourite, is colourless in acid, and actually it's a lovely magenta colour. Look at that magenta colour. I should have really done the colours for the other ones, but spotted the magenta, and that's my favourite because it's so obvious when the substance is changing from colourless to magenta or from magenta back to colourless. Now we're going to look at reactions of acids and alkalis in a minute, but you need to be able to identify if a substance is an acid or if it's an alkali. And the substances we talk about on the syllabus are oxides. So metal oxides, so things like magnesium oxide, calcium oxide, sodium oxide. Okay, if it's an oxide of a metal, so in other words things on the left hand side of the periodic table, okay, things on the left hand side of the periodic table, metal oxides are basic, okay, or they form alkalis. Even by my standards, that writing is pretty untidy. Non-metal oxides, carbon dioxide, nitrogen dioxide, where's sulfur? Here you go, sulfur dioxide, form acidic oxides. So non-metal oxides, and they are acidic. So carbon dioxide, when it dissolves in water, forms carbonic acid, H2CO3, and that's an acid, obviously denoted by just being called carbonic acid. Now these three acids you need to know about. These three we use in the lab very, very regularly. So we've got hydrochloric acid, that's HCl, sulfuric acid, H2SO4, and nitric acid, that's HNO3. And these are the formula of the three acids you need to know, and you need to learn these. Okay, there's no excuse for not knowing those. In the next video we'll look at how the acids actually react.